So continuing with the series on work solutions of the May 2024 CSEC Math Paper 2, we are on question 6, the measurement question. And in part E, we had to find the area of the shaded cross-section of this trapezoidal prism. And we got 92.5 square cm. And then this cuboid-shaped bar had the same volume as the trapezoidal prism, so we had to find the unknown height h, and we got that to be 11.5 cm. So let's move on to part B. So the trapezoidal gold bar is melted down, and all the gold is used to make 6 identical spheres. Calculate for each sphere of gold its radius, and they gave you the formula for volume of a sphere. V is equal to 4/3 pi r cubed. Now let's understand this. So the same trapezoidal gold bar, which is this shape, which has this volume 2,886 cubic centimeters, so it's been melted down to make 6 identical spheres. So the volume is going to be divided into 6 to make each sphere of gold. All right, so first thing we need to do is divide our volume by 6. So 1/6 of the volume of 2,886 is 481 cubic centimeters. So this would be the volume of each of the gold spheres. All right, so therefore 481 would be equal to 4/3 pi r cubed, the volume of one of the spheres. All right, so let us substitute pi, which again we have to use as 22/7. Okay, and our unknown we are going to find for r, the radius. Okay, so let's first multiply those two fractions together, 4/3 by 22/7, and we would get 4, I'm going to use the exact fraction, right, 4 and 4/21. Okay, so to find for r cubed now, if we divide 481 divided by 4 and 4/21. So 481 divided by 4 and 4/21. Again, I'm going to write it down as the exact fraction. 114 and 69/88. I know it's a weird fraction. And then we have to take the cube root of that. All right. So the cube root of that will give 4.9 centimeters. So that's the radius of one of the gold spheres. Okay. So let's look at part 2. Part 2 says to find the surface area of the sphere. So since we found the radius, we just need to substitute that into the formula for surface area of a sphere, which they gave us as 4 pi r squared. So 4 by pi by r squared, so 4.9 squared, and that will give us 301.84 square centimeters. Okay, so that's just one. All right, so let's go on to the last part. So we have to find the mass of one of the gold spheres now to the nearest kilogram. Given that density, the density of gold is 19.3 grams per cubic centimeter. All right, so this is 2 marks. Now, notice the units they give you for density is in grams per cubic centimeter, and the axis of the mass in kilograms. So when we find the mass, it will be in grams, and then we have to convert it to kilograms. So let us use this formula, density is equal to mass over volume, and if we make mass the subject of that formula, mass will be equal to density multiplied by volume. So the density is 19.3. The volume of one of these spheres, remember we had found it here, 481. Okay, and when we multiply 19.3 by 481, we will get 9,283.3 grams. But of course, you have to convert this to kilograms. So if I divide by 1,000, just move the decimal point 3 places to the left, so it's 9.2833 kilograms. To the nearest kilogram will be approximately 9 kilograms.